The new guest today, Nallappan has come.
I know.
That's what Bona was asking. See, no one came for our lectures and they are coming for Uma's lecture.
That's a grand finale, no, today. That's what.
No.
Hi, Prabha.
Hi.
The new guest
How are you?
today, Nallappan has come.
I know.
That's what Bona was asking. See, no one came for our lectures and they are coming for Uma's lecture.
Uma lecture is special now.
No.
Uma special always.
Today is a public holiday, no? So I
Public holiday there? Here no holiday. Here we are no. Huh? Holiday in Singapore? Hello?
Yeah, it's a public holiday in Singapore. I don't know why.
Oh. Okay. Hi, Prabha.
Hi.
Hi.
Prabha,
Is returning from college?
she is traveling by car. She is in car. I think.
I'm in the car.
Okay, returning, no?
No. Actually, I didn't go to work. I went outside, so just coming back. That's all. No college office holiday today. Long weekend today, tomorrow, day after, like 3 days we have.
Yes, so. College started for you? Only online, no? No.
No, online also the semester has not started, academic semester. We are just finishing the final year project viva and all that next week and closing it, final years.
Yeah, whether students are coming online?
No students inside the campus. Strictly no students.
Okay. Where is Prabhagar today? Prabhagar.
He's like a professor. She's asking attendance.
He was present in all the days now.
We are all professors. Mona is principal.
Oh my God!
Yes.
I know. Uma, basically professor, working as principal.
Hi, Uma.
Hi, Amangai.
You are ready for presentation.
Uma is ready at any time when we ask.
We are eagerly waiting for that.
Ushaவோட இது அனிமேஷன் தான் சூப்பரா இருக்கு.
ஆமா, என்னமோ நடந்துட்டு இருக்கு. என்னது இது?
பூஸ்ட் கன்வெர்ட்.
அது யார் எக்ஸ்பிளைன் பண்ணுவா? உஷாவா உமாவா?
நான் வேணா சொல்றேன். But it's so nice of Ushaa to get a animation picture like this.
Because you are a dedicated professor of electrical engineering.
அப்படிலாம் இல்ல உஷா, ஏதோ ஒன்று பண்ணிட்டு இருக்கோம்.
Not because cinema music here.
சரி, humble, were not accepting. நாங்கலாம் வந்து உமா வந்து ரொம்ப கிரேட்டா அப்படி நினைச்சிட்டு இருக்கோம். என்ன உமா நீங்க?
ஏன் போனா அதெல்லாம் ஒண்ணும் இல்ல போனா. Everybody can do. அவ்வளவுதான்.
Can we start?
Yes, Ushaa.
So I'll be muting all of you.
ஒரு நிமிஷம் உஷா.
ராதா.
ஹாய் ராதா.
உமா பண்ணி. ஹாய் உமா, என்ன உமா பண்ணிருக்க?
உஷா பண்ணல உமா.
உஷா தான் பண்ணிருக்கா, நான் பண்ணலப்பா.
Ready, go to Uma. Hi Radha.
Radha.
Hi.
Hello. यार अलमेलवा.
Hi Radha.
Bona.
Prabha.
Okay.
All of us are here.
We are already on live. So let me start the session.
Previous speakers all are here.
And I would like to request you all to turn off your video except Uma. And also I'll be muting all of you. And Uma should unmute herself. Can you unmute Uma?
Yeah.
Okay. So very good evening to all of you, all the participants and all the speakers. We had a wonderful 5-day FDP and we are in the last day today. And we all have gained a lot of knowledge from the day one, from Dr. N.S. Bhuneshwari and then Dr. K.V. Radha, Dr. Prabha Ravi, Dr. Alamelu Mangai, and last but not the least, our Singapenne, Professor G. Uma is here, who is going to give us a very, very good presentation and a lot of insights on modernization in the field of power electronics. And we are all eager to see the presentation. And before that, let me tell about Dr. Uma. She is a professor in the Department of Electrical and Electronics department in Anna University. And she did her BE Electronics and Instrumentation from Annamalai University in the year 1989. And she did her ME Control and Instrumentation from Anna University in 1991. And also she did her PhD in Soft Switched Power Converters from Anna University in 2002. And she started her career as a faculty in the Department of Electrical and Electronics Engineering at Anna University in the year 1992. Her broad area of research are for power electronics, renewable energy, and non-linear dynamics. And she has around 28 years of experience. And she has held some prestigious positions in Anna University. That is, number one is she has served as division head of power electronics and drives for 18 years. And she was also a department head of electrical engineering, and that is for 4 years and 9 months. And the awards and recognitions of her is All India Manufacturer Association Award. She has gained that twice for Best Undergraduate Project Guidance. And next is a very, very surprising and very interesting fact, which I came to know, that is she was instrumental in bringing 35 crores to the university under government funding Rashtriya Uchatar Shiksha Abhiyan. A very, very big round of applause for you, Dr. Uma, for your responsible contribution to the university. And I should also say that when I say this, you're an asset to the university. At the same time, I should also appreciate the university for giving freedom for all their professors to do a lot of research and contribute a lot for the students' growth, and also give a quality education, and also for the benefit of the university. You all have a very, very good opportunity which is provided by the university. So a special applause to the Anna University too. And she has guided many students, and of her students, 13 students have got their PhDs, and also she has guided for 2 MS by research students. And she has many papers, that is 80 publications over the national and international journals. And she has got an H index rate of 19. That is, H index is the author level metric that attempts to measure both the productivity and citation impact of the publications of a scientist or scholar. And also she has got an I-10 index of 44. That is the number of publications with at least 10 citations. So this shows her as a truly a good researcher. And we are very, very happy to welcome you for this session. And again, I'm glad to tell that I'm Uma's classmate, rather than me saying that Uma is my classmate, because whenever I meet anybody from Anna University, when I introduce myself as a CEO of a company or a principal of an engineering college, there won't be a big recognition. But the third thing, when I say that I'm a classmate of Professor G. Uma, who is head of the department of EEE in Anna University, the way they resume me is totally different. And similarly with Dr. Radha, whoever know her in the AC Tech, really mind-blowing reputation which they both have got in the university, and the respect what we get when we say that we are their classmates. So that is, I feel very proud of you, Uma, for the way you have been maintaining your reputation right from day one from the college. You have been very sincere towards your studies, and till date, I'm seeing you as the same person. You don't have any other diversion. 100% your concentration is on your career and your family, and you're a very, very disciplined, methodical, structured human being, and we're all proud to have you in our group, and also proud to say that you're our classmate. So over to you, Uma.
Thanks a lot, Ushaa. Thanks for an excellent introduction, which I have never heard from other introductory speeches. Thanks a lot. And first of all, let me thank Dr. Ushaa for inviting me to this FDP. So it's a great opportunity for me to meet my own classmates who are all not connected for so many years, and we are able to recollect our own green memory days. It's a very nice opportunity, and I don't feel like being aged or something. It's we are going back to our own college days. It's very, very nice, and it's an excellent opportunity. And congratulations to all the presenters who have made an excellent performance in the last 4 days. And let me talk. I did my graduation is from electronics and instrumentation, and then I switched over to. I happened to get a job in the Department of Electrical and Electronics Engineering. That's why. But once I joined in the department, I know about digital electronics, instrumentation, only those control system subjects. Only those things I was aware of that. But many of my colleagues, they'll be talking about power electronics, power system, high voltage engineering and machines and all. But I felt at that time that I was an odd man out in the department. So practically, so somehow we have to cope up the needs of the students. I can't say that I know only these subjects. I don't know the other subject. Like I can't keep on saying like that. So I started learning power electronics. This thanks to my teachers, our teachers, Dr. C. Palani, who gave an introduction about power electronics. He made every one of us to stand on the dais, asking us to consolidate whatever he has taught in the previous class. Hope every one of us remember that. Okay. It was a great thing, and it was also very nice that I happened to teach the son of Dr. C. Palani. He was our student. It's a nice opportunity for me. And power electronics, I should thank my own guide, Dr. C. Challamuthu, who was inspiring me to learn about power electronics. So initially, I don't know. We all learned. Many of our own classmates are here. We have seen only the book Ramamurthy. We have a symbol power electronics by Ramamurthy book. It has one symbol about the SCR in the first page. And frankly speaking, I didn't. By understanding power electronics, I did not pass the subject power electronics during our college days. Okay, something I learned, and somehow I got a pass mark. But after, because at that time, the awareness, the nature of the connectivity, the number of textbooks availability, everything, it's was limited. Now, so many opportunities are available, and I devoted some time to learn about power electronics. And in my understanding, power electronics, I am able to get few publications in the power electronics domain only because I was an instrumentation engineer. Only because of the since we had a very good basics, thanks to Dr. Vaidilingam sir, SPN sir, because of their fundamentals only, I was able to succeed in this area, because all the control systems and the signal conditioning, linear integrated circuits, all the fundamentals, they form the core of the power electronics. Power electronics is a device, but to control the device, all these interdisciplinary these things are necessary. Since our teachers taught us very well about the subjects, I am able to do something. I'm able to keep a step forward in the direction of the power electronics. Okay. Shall I start?
Share the screen, Uma.
Okay. Okay, let me share because people are from, we have our own friends and people are from different diversifications. Let me share some, the role of power electronics for utility applications. So utility in the sense, I'm not talking about the entire power system, where and all power electronics is going to play a major role. First point is, power electronics is simply a device. Normal signal electronics is the voltage and the current are at the lower level. Power electronics is handling of voltages and currents at a higher level. So power electronics, the power devices are operated in the switched mode. That's all, on or off. That's all. So the control of the power electronics, everything comes outside the power converter, which has nothing to do with the converter or inverter, whatever you have heard about from other domains. Okay, it is basically a switch. So you could have come across different types of switches, the power switches, power switch. So normal switch and a power switch. A normal switch, the voltage and current ratings are less in the sense 230 volts or 5 volts or 2 amperes or 5 amperes at the low voltage level, low power level. Again, when we talk about a power device, the power device has to withstand. The power device will operate only in two modes, one in the on mode or in the off mode. In the on mode, it has to carry heavy current, thousands of amperes or tens of thousands of amperes, like that. In the off state, it has to block the voltage, blocking hundreds or thousands of kilovolts. These are the two important requirements of a power device. Okay. After this requirement, is it possible to manufacture a power device? Until 1960, the only device, or I can say that the vacuum tube devices were there. Then 1960, the first power device that has entered into this domain is a SCR, silicon controlled rectifier. You would have seen the symbols in many places. Okay, in many of the textbooks or even in the equipment, you could have seen the symbol. So it's SCR. SCR is a silicon controlled rectifier, and it has its own property called the latching property. Parallelly, the semiconductor revolution took place in 1960. Due to that, BJTs, MOSFETs, everything they also, the people, it has started the popularity of using those devices in the signal side had started increasing. So the next in 1980s, the power people, or not the power people, not an electrical engineer. It is basically the physics, the device fabrication people. It has started only from the physics domain. So they started manufacturing. They started applying these low power electronic principles for the fabrication of the high power devices. So based on that only, we have many devices have emerged, like power BJT, bipolar junction transistor, power MOSFET, metal oxide field effect transistor, like that. The signal devices have been transformed into the idea of the signal devices were applied for the fabrication of for the production of the power devices. So it was a great revolution in the power electronics. That's why I normally used to say to the students that until 1990s or until 1990, so you can see textbooks still now. Many of the colleges, they are using textbooks with SCRs, but apart from SCR, now SCR became very, it has the application of SCRs has now it has narrowed down. Due to the advent of the other devices, due to the other popularity or the application utility of other devices like power BJT, power MOSFET, power IGBT, and so on. Now the domain of the power electronics has taken a new dimension. So now I am talking about BJT, MOSFET, like ABCD devices. So after 20 years or 15 years, some other ABCD devices may emerge. Okay. Now at this point, first one thing everybody has to understand is power device is a high voltage blocking capability and high current carrying capability. That's all. And it has to turn on and turn off at some particular rate. These are the three important criteria we have to look into while selecting a power device. Now, IGBT, I want to mention about an IGBT device. The expansion is insulated gate bipolar transistor. This I can say that we are talking about power electronics, and India has also got a special scheme called a NAMPET, National Mission on Power Electronics Technology. It was introduced during the earlier government period. It's a national mission to promote power electronics. There was a national mission was created to identify the importance of power electronics. A national mission was introduced by the then Prime Minister. So that is because power electronics is finding applications almost in all the areas. And IGBT, as I was, let me come back to the same point. IGBT, insulated gate bipolar transistor, it was invented in or in the early 1990s. It was invented by an Indian scientist called Jayant Balika. So he was awarded Nobel Prize for that. So we should be proud of that. So because after the invention of IGBT, there is a major revolution in the power electronics technology. That's why the NAMPET mission, everything, almost in all the electrical gadgets, starting from very low power, milliwatt to megawatt, all the appliances, they have a built-in power conditioner, which involves power electronics. So before going into the entire definition of entire coverage of the power electronic applications, this is the first thing I want to share. That is, power electronics is basically a device. That device, what are the devices that are available, and one has to identify the suitable device for the corresponding application. That's one as an application engineer, one has to look into that. Okay. Now let me just go into the overall scenario of the. Let us see how, starting from the power grid until the last end user stage, how power electronics plays a vital role. The first one is one nation, one grid, and one frequency. This is the title. First, we have power. Power is produced in the different parts of the country, and we need to transfer the power from one place to another place based upon the locality of the industries and the loading requirements. So grid management on regional basis started in 1960s. So initially, state grids were interconnected to form a regional grid. And we are in our country, we have 5 regions, namely Northern, Eastern, Western, Northeastern, and Southern regions. Each grid will operate independently. They will have their own power producers, and they will have their own transmission lines and utility. But it was not possible to transfer the power from one region to another region. So then the national mission, it is nationwide. It was found that there was a necessity to interconnect the grids. So interconnection of grids was proposed, and in that this interconnection started in a phased manner. So in 1991, northeastern and eastern grids were connected, and again subsequently in 2003, western region and the eastern, and they were connected. Again in August of 2006, north and the entire northern grid, they were under synchronous operation. So they will have synchronous operation, means we all know that our AC supply is operating. We have AC supply sinusoidal in nature because it varies instant. It has a time variation. It varies instant to instant. Therefore, synchronization is very important. So, the northern region, all the loads in the northern region, they were synchronous, and we have the southern region. We fall in the southern region, and we were having a separate grid. But under the mission of one nation, one grid, and one frequency, in 2013, the southern region and the northern region, they were interconnected via a Raichur Solapur transmission line, 765 kV transmission line. So with that, the entire country comes under the code one grid and one frequency. This is a major achievement in our side. Okay, this is a simple picture illustrating who are all the power generators, power producers, and how the power is being shared from one place to another place. This you would have seen in many places. I have taken as an illustration to show where and all power electronics is applied in the grid. Okay, first we have central power station. We have the central power station. So power grid, all the power generated will be pooled into the grid, and the consumers or the load users, they will be tapping from the central grid. So we have different types of load users, the consumers. starting from very large industries, let us say starting from our own cell phone chargers, battery chargers. Okay, earlier, some 10 years back, we used to have one battery charger or eliminator. Probably everybody has used that eliminator, which was a brick size. The plug-in, when you plug the socket into the supply system, we used to have a very big eliminator, very big. It was like a small brick. The size of the eliminator will be bulky, and it was the approximately a small brick size. It will be there. Probably everybody can understand that, because this is due to the size. If we take electrical engineering, only there are 3 components: resistor, inductor, capacitor. So resistor is going to consume the power, and it is going to do the useful work. So L and C, the other 2 elements, L and C, they just take part in the system. They help in the power conversion in the desirable manner. That's all. Okay. So earlier, when we have an eliminator 10 years back, that very big eliminator with the head of the eliminator will be very bulky and heavy. So it was due to the use of a very transformer which operates at a power frequency 50 hertz. Okay. So when you want to connect a battery into a radio or a tape recorder or something, any electronic gadget, low power device, into the 230 volts mains, we require a converter, AC to DC converter. So this converter it had a transformer which converts AC into DC, then condition. Since the converter operates at the line frequency, the size was heavy, bulky. Now, the same eliminator now we are using, the present day eliminators, day by day we are improving the compactness, because all the conventional transformers or conventional power devices, low frequency devices, are being replaced by high frequency devices. High frequency offers compactness, improved power density, space saving, everything. So even if we take a laptop which was weighing a few kilos, whatever the laptop you bought 2 years back, if you buy a similar one now, it will be comparatively it will have a less weight, because the weight in the laptop is owing to the use of the switched mode power supply. The switched mode power supply has batteries and converters and different power conditioning units there. So all day by day, the improvement in the power electronics is miniaturization, improving the power density of the power devices, so that for the same power we are able to get in a smaller with a less volume and in a smaller space, we can accommodate the same converter. That is a major revolution in power electronics. So compactness. So if you look into the same diagram, we have different types of converters. Let us say if we have an adjustable speed drive, for example ASD, I have mentioned about ASD, adjustable speed drive. So there are certain industries where speed variation is very, very crucial. A paper industry, or a cloth textile industry, where the thickness of the end product has to be maintained stringently. Only then, if there is any speed variation in the motor, then the end product will become, it will not meet the standards or the specifications. Therefore, there are certain places, there are few industries or certain industries, they require tight speed control. So adjustable speed drive becomes an essential part. So what is adjusting it? It is adjusting even though the supply fluctuates, it is maintaining the adjustable speed drive has a built-in power electronic conditioner such that it controls or it maintains a desired speed on the end user side. This is an example. Similarly, if we take a wind farm, we are due to the depletion of the coal and other resource, people are now we started using renewable energy sources. If we take a wind energy conversion system, we have different generators, wind electric generators, starting from a micro wind turbine to very large wind turbines. The wind turbine, the nature of the power generated by the wind turbine, they are intermittent and varying in nature. So cannot be directly used for the load. It has to be conditioned. As an example, let's say a power conditioner. What is a power conditioner? We have normally we can say that if 2 people want to get married, then there is a horoscope matching. The same way, available power may be in one form, the desired power, the requirement may be in other form. Therefore, all the power converters, they act as an interface. They act as an interface. They match the supply VI requirement with the load VI requirement. That's all. So that thing, it's basically a switching device matching the available source with the desired load requirements. So if you look into the almost in all the places, we have a power conditioner. Then if you look into a transmission line or a power grid, the voltage regulation at the power voltage, let us say, you know about people are working with a signal devices, they know about 230 volt single phase supply, 440 volts three phase supply and all. So when we talk about 440 volts three phase or 230, so the voltage has to be at the rated value, single phase or three phase, and the frequency has to be at 50 hertz. But normally these things will not be there, because sometimes due to some overload or some natural disturbances, the frequency may fluctuate. Voltage will not be at the rated value. But some of the loads, they require a tight voltage regulation. So we can connect voltage, static VAR compensators, SVCs, like that. Let us say this is one such a unit of power electronics. And if we take one power grid, this is one circle power grid. This is all the generation are pulled into this power grid. There is one more power grid, another generation, nuclear power, thermal, everything, they are pulled into this power grid. And if you want to connect to, because it is operating at 50 hertz, it is operating at 50 hertz, but they are not time synchronized. Okay, they have to be synchronized in time. Let us say Ushaa is starting the seminar at 5 o'clock, means I am synchronized at 5 o'clock, because similarly Mr. Nallappan from Singapore, he is also synchronized for our time. His clock is different, but he is synchronized to our clock. Therefore, the power has to be time synchronized. Therefore, this time synchronization, the power grid, one power pole, the another power pole, if we cannot connect it directly, you should have a conditioner. Either you can have a frequency, suppose one is operating at 50 hertz, another one at 60 hertz, you can have a frequency changer. So we can also convert, one other possibility is you can convert available power AC into DC and transfer, and at the receiving end on the other side you can convert DC into AC. This is one application, or simultaneously from on the other end to this end. This is the one. In the case of DC, there is no synchronization. If you take an AC signal is a very beautiful signal. So if you take it is we cannot connect one AC signal to another AC signal instantaneously. It has to be synchronized. The zero crossing of both or everything has to be synchronized. Then only we can connect. Whereas there is no synchronization in the case of DC. It is constant. Therefore, one such application is convert AC into DC, transfer via the transmission lines, and give it to the other, where employs more converters there also. Then you can use it, you can do the power transfer by this way. Okay. So in the Indian scenario, India is a world's third largest producer and third largest consumer of electricity. The national electric grid in India has an installed capacity of approximately 37 gigawatt as of June 2020, and the various shares of the central and the state and private sectors are shown here. This is all these things I have taken from the internet. And similarly, the shares of the various regions are also shown here. If you want, you can use it later. Okay. So regarding the transmission, the transmission is an important part of the power delivery system, and we have, I was telling about the five regions of the country, and the Power Grid Corporation of our country is the central public sector unit looking after the power transmission. Okay, there are two types of transmission. One is the AC transmission, another one is the DC transmission. In AC transmission, the highest voltage achieved so far is plus or minus 765 kilovolt. That's what the extra high voltage AC transmission is, 765 kilovolt. Why we are going for high voltage transmission means, suppose we have many independent producers, independent power producers in one area. All the power producers can be pooled and they can be connected to a transformer, primary side of the transformer. On the secondary side, we all know the transformer can step up or step down the voltage. So all the power producers, local power producers can be pooled and connected to the primary of the transformer. On the secondary side, the voltage can be stepped up to 765 kV. Even 1200 is in the development stage. So the voltage can be stepped up to very high voltage. Therefore, current on the secondary side will come to a very less level. So voltage, when you transfer, when you convert the power, when you power on the primary side at low voltage high current is converted into a high voltage low current transferred via the transmission lines. When the current becomes small, the size of the conductor also will become small. So that's the power losses. When we have the conductor, there is an inherent very small resistance associated in the conductor. The power loss, the conductor loss also will get reduced. That is, and with the extra high voltage or HVDC transmission, it is possible to enhance the power transfer with the same conductor. It is possible to transfer the large amount of power. That is the advantage. And in the case of, there are two, as I mentioned earlier, there are two transmission, HVAC, the maximum voltage used in India is 765 kV and 1200 kV is under, the design is under the process. And there is parallelly, we have a high voltage DC transmission, which where the maximum voltage is 800 kilovolts. These are the different, under the different 5-year plants, the circuit kilometers. We can see that circuit kilometers, the transmission lines constructed under the different 5-year plants of the country, they are given in the circuit kilometers. Similarly, the substations, the capacity of the substations installed during the various 5-year plants. This was a national scenario. Okay. Now coming to the role of power electronics in the grid side. So due to the, until say before the usage of power electronics or earlier, we had a central power producing station, and from where the power will be routed or distributed to different parts of the country or the different networks. But due to the decreased use of decreased use of natural resources or the fossil fuels, we tend to use renewable power. The renewable power, we can penetrate the renewable power into the grid at any place. Okay, so due to the use of renewable power, the distribution end or the transmission length is no longer a passive network. They become an active network. Passive network in the sense, earlier from the central power producing place, power gets routed to different places. But now with the renewable energy sources, you can generate and use locally. The rest you can transfer into the grid. That is a policy. You generate, let us say we in a simple house, we can put some rooftop solar or a micro wind turbine, something like that we can put. We can use it for our own household appliances. The rest of the power you can transfer upstream into the grid. That is one such application. Like that, now that we started generating power using renewable energy sources, and hence that grid. It is a high time for the grid to get modern grid. Okay, that's why I have used another slide. A conventional grid, it has a characteristic of unidirectional power flow with the centralized generation, whereas the requirement of the modern grid is a dynamic fast response grid with distributed generation and bidirectional power flow. Okay, you can transfer the power, whereas in the former case, in the case of unidirectional, you can, from the neighborly or thermal power station, you can draw the power, you cannot send it there. Therefore, the same here it is possible to have a bidirectional power flow. The advantage of bidirectional, it is numerous. I'll tell you in the subsequent slides. So this has enabled us to use a smart grid technology. As Mr. Nallappan was telling, he was working. He is working in I 4.0. Industry 4.0 is an era of digital communication. So all the devices, they need to communicate. They have built-in sensors, communication protocols, everything. They will communicate via the digital communication links. Therefore, this has also like we starting from a small LED light which has a built-in sensor. So in the similar way, the entire power grid is also made into a smart grid, which with the built-in sensors and communication protocols and everything. So this has led to the due to this renewable power, the penetration of the renewable power, and due to the adaptation of the different digital technologies, the grid also gets modernized, and it has led to the development of the smart grid. So this is the domain before smart grid. This is an example of the network from the generating station, step-up transformer, transmission line, again step-down transformer, then distribution. After smart grid, let us say the loop, anything can communicate with anyone. That's right. If you look at the loop, all are communicating. So from the power station control sector, we have a control sector. In the smart grid architecture, we can have different layers of the control structure also. Like when you write a software, first layer, primary layer, secondary layer, like that, we can have different layers of the architecture, and it has a very beautiful technology to control this power flow. So coming to the conventional grid distribution end, we have distribution means whatever we are receiving at the load end or at the user end, we have from the city income, for example, in India, the city in feed or incoming voltage is 11 kV. From 11 kV using the distribution transformer will be stepped down to 440 volts, and from 440 we'll get a 3-phase 4-wire system, we may get 230 volts. Am I fast or shall I slow down? Ushaa, shall I go?
Go ahead.
Okay. Okay, we have a through the distribution transformer, all the loads are getting connected. And if you look at the modern grid, the transformer itself will become a static transformer. Not far are the days that we'll be witnessing the no longer the big transformers that we see on the roadsides. No longer it will be there. It probably in our future generation may see these the solid state transformers, where built-in power electronic devices with the built-in power electronic solid state transformers. Solid state doesn't mean that there is nothing called liquid state. Okay, it's a popularly called a solid state transformer using a device. So the conventional big oil-cooled transformers will no longer be there in the future generation. Okay, so all these things will be replaced by the power electronic devices. And if you look into this end user side, they are bidirectional in nature, and it can communicate. That's a very thing. So one main thing about power electronics one has to understand is one should not fear about power electronics. Okay, it's only a device that we can control. The associated instrumentation is very important for the control of the power electronics. If you are good in instrumentation, it's very easy to learn about power electronics. Very, very simple. Okay, the major areas power electronics and utility applications: reactive power control, active power control, voltage control, current control. See, n number of applications I have listed, and people are from different domain. And don't worry about these applications. What does each one convey? Okay, we have fundamentally one fundamental principle is the electrical network is composed of R, L, and C. Nothing more than that. L and C will create oscillations, and they will draw some reactive power, because it will make the current to either lag or lead the voltage. Like that, it will do some work. So based on our requirement at the load end, you can control this L and C. First of all, as I mentioned, R, L, and C. When I say 100 watts of power is being consumed, 100 watts is the power loss only in the resistor. Neither the inductor nor the capacitor is going to consume the power. Only power loss or the power. Let us say I'm putting an AC in my room. The AC, the cool energy is due to the resistive loss only. Okay, heating energy, everything. Whenever work done component is only by the resistance, by the power loss, by the power dissipated in the resistance. Inductance and capacitance, they just take part in the system. But without inductance your transmission, it is not possible to transfer the power via the transmission line, or the machines or the transformers will not work. So they are required for the operation of the proper operation of the system, but they do not take part in they do not consume any power. Okay, so all these applications, the applications name may be very fascinating. Don't worry about all these application names. It is basically how we control L and C. How we control L and C, it is possible to achieve the different objectives. That's a simple thing. Okay. Now, as I mentioned earlier, when we have passive L and C, we have passive filters. Some of you would have heard about the passive filters. A single L, single C. A reactor will be a bulky in size, a capacitor. So, in order to overcome the bulkiness of the filters, they occupy more space and bulky, and when you want to tune a filter, after some time the detuning may happen due to aging of the components, aging of the devices. Detuning may happen after 3 to 4 years. The frequency, when you take an LC, there is a resonant frequency. Therefore, the resonant frequency will keep on changing, and all those things can be circumvented by using power devices. You can artificially generate using a power electronic device in conjunction with an LNC device. You can artificially create a high frequency L and a high frequency C. That is a very simple principle. Accordingly, we can have different names, different applications, but each application, what I want, if I want a voltage control, I want to have a capacitor. That's a simple thing. So how come I want to do the fine control of the voltage? So how do I do the fine control? I have a solid state device in conjunction with a capacitor. So by smoothly varying controlling the solid state device, it is possible to do the voltage control. So all the applications, nothing to do with nothing. No, don't worry about in any of these applications. So it is how we are going to manipulate LNC, how we are going to vary the reactance in conjunction by using power electronic devices. Accordingly, the application may be different. Okay. Next, the role of power electronics in transmission systems. Flexible AC transmission systems. You would have heard about flexibility, flexible manufacturing system, flex additive manufacturing systems. Therefore, like 3D printing and everything you have heard about. The same way, when I want to transfer the power, when I want to increase my power transfer capability via the transmission line from one end to another end, then each transmission line, originally it was constructed to carry some desired amount of power. But if I increase the power through the same line, then overloading may happen, and sometimes the loss of outage may also happen. So with the flexible AC transmission system, it is possible to enhance the power carrying capability of the transmission line without additionally constructing new power lines. That is the advantage of the fax devices. We can also call it as a fax devices, because the devices are constructed, the devices are the fax devices, they all involve power electronics. Another thing about power electronics is, we all know about, I'm recalling our own student days, the simple device SCR. Probably the same information you can definitely pass on to your children or whoever wants to take about electrical engineering, because many of them, even in the newspaper 2 days back, I read that in many of the places, power electronics and drives, they are in many of the colleges in affiliated and Anna University, they are going to close the ME program, it seems. That's what I read in the article. And many people are not willing to join BE electrical and electronics engineering. It is not so. It is a very beautiful subject, because I have seen the other part also. I have studied electronics, and but it's a very, very beautiful subject. Only thing is some understanding. We need to devote some time for the basic understanding. If you understand that, it's a very, very beautiful world. That's all I want to say. And the fax devices, we have flexible AC transmission devices. We have series connection devices. If we look into that, it's a shunt connection device, but the title is under series compensation. No, let us say a compensating device. This is a transmission line from source 1 to source 2. V1 is a transmission end. V2 is a receiving end. And if we look into this, due to the presence of the inductance, the terminal voltage V2 will be different from V1. So we can add either a series compensating device or a shunt compensating device. So let us say if I want to regulate the voltage at V2, I can introduce a series compensating device. If I want to control the power flow at V2, I can introduce a shunt compensation device. That's the objective. So what is inside the shunt compensation? It is only a simple thyristor. That's all. So we have different, I'll show the diagram. We have different combinations of the fax controllers, series shunt, and a combination series. Okay. If we look at a series connected controller, a fax controller, to regulate the voltage of the other end, we have a SCR based controller. The SCRs, if we talk about the AC systems, SCRs are still the workhorse for power transmission. I was telling about IGBT. First, when at the end of the session, at least you should be able to, the takeaway point is, the SCRs are SCR, we have one called SCR. or a Thyristor family, another one called the BJT or the transistor family. So power devices have started emerging both in the Thyristor family as well as in the transistor family. But in the case of the property of the Thyristor is it is a latching device, controlled turn on and uncontrolled turn off. That is a property of a latching device. It's a single control, it's a half controlled or a controlled turn on and uncontrolled turn off. Like that we can say for a SCR. Whereas if we take a BJT or a MOSFET, it is a fully controlled device. Therefore, SCRs are suitable for AC systems, because we have a natural zero crossing of the supply. Therefore, due to the natural zero crossing, the devices will come to the off state. We need not construct any extra units to commutate the device. That's the advantage. And throughout the world, still, if we no device has come for the competition of the SCR, because it is possible to manufacture SCRs with a higher blocking voltage in terms of tens, hundreds of kilovolts and higher current carrying capability. So we know that we all have studied basics of devices. It is comprised of, if you want to understand about the device, we have different PN junction layers. Okay, the different PN junction layers, we need to increase the resistivity of the layer by adding impurities. So in the fabrication stage, it is possible to produce, in the case of SCRs, it is possible to produce SCRs with a higher blocking voltage and a higher current carrying capability. And they are suitable for the low frequency range. The low frequency in the range, power frequency, 50 Hertz, 100 Hertz. In that range, it is suitable. But that's why if you look into the few slides, the fax devices, there's a flexible AC transmission. To increase the power carrying capability of the existing, to enhance the power carrying capability of the existing transmission lines, these power electronic devices are placed either in series or in shunt in the transmission line. That's all. So, but these fax devices, mostly they will be using SCRs for their control. Okay. That is also called a series controller. Each line will have a series controller, and you can have a coordinated controller by having a combination of these two. It's called the shunt series. So the only objective in the transmission line is either voltage or current. That's all. If you want to enhance the voltage, use a series device. If you want to enhance the power, use a shunt device. And the shunt or series, again, it is a combination of the power device. That's all. This is a Thyristor controlled series reactor. You can control the reactance. The one culprit in the case of transmission line is the receiving end voltage will be far different from the sending end voltage only because of the line drop. Line drop occurs in the inductance. So to improve the voltage profile at the receiving end, we have to introduce an artificial booster. So this line reactor, this controlled reactor, you can alter the line reactance by having a combination of this SCR. That's all. So by controlling this, by intelligently, say I'm telling, by intelligently controlling, by this, everything comes away from the converter, nothing to do with the system. Though external control mechanism should control the device in such a way that whatever we want, either we want to improve the voltage or if we want to improve the current, that everything is possible. Okay, this is capacitor. For all are in the case of electrical engineering, it is very beautiful. When we have current voltage, when you have a Thevenin's theorem, you have Norton's theorem, shunt and series. So they are always the duality exists in the electrical engineering. So the same way the same dual system. Either I was telling about the inductor, now I am telling about the capacitor. So duality is a very beautiful analogy present in electrical engineering. So next one is the static series compensator, triple SE. So triple SE, it is nothing but again a three-phase inverter, voltage source converter. If you look into the diagram, the circuit diagram, whatever I have shown, this diagram, this converter, we can say this finds application in numerous places. I can call this as a voltage, I can call it as a triple SE when I put it in the transmission line. The same three-phase topology, if I use it in, for example, whatever the rest of the people know is, if I use a three-phase inverter, a domestic inverter, for example. So I can, if I use, then it has a battery, and instead of having a capacitor, you can have a battery, and it can be converted, DC can be converted into AC. So the same thing can also be used for power generation. If I instead of having a, let's say, HVDC transmission, VA, VB, VC, you can connect what AC supply, it can be converted into DC on the other end. So numerous applications are possible with this topology. This is called a voltage source converter. The next one is static VAR compensator. The static VAR compensator, it is mainly used to improve the power factor. So as far as the end user, as far as the distribution end is concerned, whatever VA, we have studied about 3 types of power. One is the active power, apparent power, and the reactive voltamperes. These are the 3 parts. Out of the 3 powers, active power is the one which is physically realizable. Physically, it is going to do the useful work. The remaining ones are fictitious for us to understand the concept of electrical engineering. That's all. So the n number of reactive distortion voltampere, and so many definitions are available. But despite all the definitions, the one which is the one component which is responsible for work, for doing the energy conversion is the active power. So same way, if I want to, so normally we used to say we will be maintaining, we need to maintain the power factor closer to 1. Power factor means, power factor is no longer cos phi. Power factor is no longer cos phi. Cos phi, in our undergraduate engineering, or when you talk about when a student learns electrical engineering for the first time, he'll be drawing a sinusoidal voltage, sinusoidal current. The cosine of the phase angle between voltage and current is the power factor. That's how we used to learn. But when we are introducing controlled devices, even a simple introduction of the simple diode will alter the property of the sinusoidal signal. Therefore, in that case, power factor is the ratio of the work done, ratio of the power consumed by the load, ratio divided by the volt amperes. So that is a very important part. Volt ampere, that's why in commercial terms, we used to say kilowatt to kVA. So when the ratio of kilowatt to kVA indicates the line utilization. Line utilization means how effectively we are going to utilize a line. Okay, because suppose if a person earns 10,000 rupees, for as an example, if 10,000 rupees, if whatever he earns, if he is going to spend usefully for the education or for some domestic work, then it is good. But out of 10,000, if he is going to spend some 2,000 or 3,000 for some transport or some unwanted work to reach the home, then that 3,000 is not part of the work, part of the useful work. In the same way, we have the kilowatt to kVA, we need to maximize kilowatt to kVA. Then only whatever VA we are drawing from the source, everything has to be converted into useful power. Therefore, to maintain the power factor, we need to inject artificially some reactive voltamperes. That is possible once again with this compensator. That's the point I want to share. So many diagrams I will be showing, but you will be don't worry about all these things. One fundamental concept you take away is you control the reactance. Either it may be a capacitive reactance or it may be an inductive reactance. You control the reactance by using switching devices. That's all. This is another configuration, another switched capacitor, another STATCOM application. There is also called Interline Power Flow Controller. It's a combination of series or shunt series combination. You can control the power. You can transfer the power from one line to the other line by controlling the power converters. There is also called Unified Power Flow Controller. Combination of static shunt and series controllers. Okay, these are all the different fax devices. The fax devices enhance the power transfer capability in an AC line by incorporating. It also eliminates the need for the construction of the additional transmission lines. With the same transmission line, it is possible to enhance the power transfer more power using the fax devices. It also has certain drawbacks because maintenance, the moment you use a power electronic device, the periodic maintenance, we need to have redundant systems to maintain continuity of the power supply. Suppose if the converter fails, then that line will be, the outage will happen. So to maintain continuity of the supply, we need to have some redundant networks, and initial cost involved for building up the converter will be high. So those things are all the limitations of the fax devices. Okay. So to circumvent or to eliminate this, the other option available to the user is the high voltage DC transmission. Okay. So available AC power will be converted into DC and transfer via the transmission lines. When we have DC, only we require only two wires, plus and minus. Transfer via the transmission lines. Again, at the receiving end, we convert DC into AC. Because why we are doing this conversion means, as of now, all the appliances, all the loads, electrical loads, they are designed to work only in AC. That's why this power conversion is necessary. Therefore, for bulk power transmission, for transmission of power in terms of megawatts, this HVDC transmission is the best option. So we have a transformer, rectifier, power is transferred via the transmission lines. Then on the receiving end, we have inverter and HVDC transformers. So this again, the advantage, this we are going to enjoy by the use of power electronics only. Again, the HVDC transmission is possible. It is done only using SCRs, silicon controlled rectifiers. No device has come for the competition of the SCR still now in the entire world for the HVDC transmission. Okay. There is also something called HVDC light, back-to-back connection, that they are using the controlled devices like IGBT. But for bulk power transmission, SCRs are still used for power transfer. So advantages and disadvantages I have shown, and we have different types of HVDC transmission system. Your monopolar link, unipolar, homopolar, bipolar, so many links are available, and it is a it is also very HVDC links under it is also possible to have run cables under the sea. So that's onshore HVDC systems are also possible, and popular links are present in the and it employs. I just bypass these things. That's what we have, monopolar link, where we don't have a return. If you look into the return part, there is no return, only one line will be there. And it's a bipolar link. We have a positive and negative. We have homopolar, only one negative polarity alone will be there. Okay. So applications of HVDC systems, it is mainly used for bulk power transmission. Order of the power is of the megawatts. Through underground, so that's what I have mentioned, bulk power transmission through underground or underwater cables. It is also possible. Interconnection of individually controlled AC systems and stabilization, and it is also, there is no, DC does not have any frequency. We don't have any reactance effect in that lines. And the popular HVDC links in India that I have listed here, and what is the capacity of each link, bipolar line plus or minus with the voltage level of plus or minus 500 kV, and what is the power transferred in each line, that all are taken from the website that I have shown here for your understanding. These are the different numerical information. There is also one thing called the MVDC transmission, HVDC, high voltage DC. There is one thing, a medium voltage DC transmission. So this is generate power locally from different wind turbines or solar, convert into low voltage, plus or minus 50 kilovolt, or according to the defined zone. It is transfer via DC link. Then it can be converted. Then it can, this plus or minus 50 kV MVDC can also be interlinked to an HVDC line. You can suppose if a HVDC line is running from one place to another place, you can generate solar power or wind power locally in that area. If suppose the potential, if it is possible to harness the wind power or solar power, you can generate it locally. Whatever we have generated, you can penetrate into the HVDC line. That's what it's shown here. You can generate the wind turbine, they have generated, and all the wind power is converted into DC via DC-DC converters. Then from here, it can be plugged into the HVDC line also. This is the MVDC transmission. Okay. This is a very popular, everybody knows about the different components of a grid: generating station, primary transmission, secondary transmission, primary distribution, and secondary distribution. So this normally we used to ask to the students. This is the first one. As an electrical engineer, everyone should know that's a primary, the voltage generated at the generating station. Let us say Neyveli or Ennur, it is 10 kV or 11 kV, but thousands of amperes. And from there, the primary transmission takes place to very high voltage of the order of 765 kV or something. So then again, primary transmission, then secondary transmission. In the secondary transmission, it will be converted into 132 or 230. Sorry, it's a primary transmission. Again, it is step down to 230 kV or 66 kV or 11 kV, something like that. In the case or something in the case of secondary transmission. Again, primary distribution takes place at 11 kV, 12 kV, or 13 kV. These are the different voltage levels I have given for the primary transmission and the secondary transmission. Again, primary distribution from 132 kV or 66, it depends upon the substation voltage level. Okay, city in feed. We have, but primary distribution begins, secondary distribution begins at 11 kV, from where it is connected to different industries or to different consumers. One important point I just want to, okay, coming to the nature of the loads, we have two types of loads: electrical nature, we have domestic loads, power system loads, large industrial loads. Industrial loads will be connected only in the HT line, and domestic loads will be connected in the LT line. That information you all aware. And so this is an important point I want to touch upon in today's lecture. We have a broadly distribution system, whether you can use single phase supply or three phase supply. Accordingly, we have 3-phase 3-wire or 3-phase 4-wire systems. The loads, industrial loads, the can be classified. All these things, anything which consumes power is called as a load. That's all. Okay. The nature of the loads. That's this point I want to emphasize here. The nature of the loads. They may be classified either as linear or non-linear. So in colloquial term, we used to say linear. When a person, whatever, when two persons, whatever we say, the student agrees, or if another person, whatever, what children of they obey, then we can say that he is a linear person. Okay, he will obey whatever we do. He will take and he will execute. But if he is doing, if the other person does the work in the opposite direction, hey, he is non-linear. He will not follow whatever we are telling. It's a common word we used to say. But in the same way, the loads, the broad classification of the loads, a linear load. The load, suppose if a load is nothing but one which draws the current. That's all. It may be any electronic gadget, any industrial load, anything, any one which consumes, it draws current from the supply is called a load. The load, if I am connecting a load to an AC supply, very, very colloquially I am telling, if I am connecting a load to an AC supply, the load, if the current drawn by the load has the same sinusoidal variation as the of the voltage, then it is called a linear load. Then let us say if I connect a DC, if I connect a DC supply to another DC load, then if the current drawn is quite DC, then it is a linear load. So current drawn, the nature of the current has to follow the nature of the voltage. So if there is any deviation, then it is called a non-linear load. That's the main understanding. So non-linear loads draw current which are non-sinusoidal in nature, or chopped. If we take a DC voltage, then it will draw current in a chopped manner. Chopping is cutting like that, on off like that. So non-linear loads draw current which are non-sinusoidal in nature. So non-sinusoidal is due to the use of due to the drawing of the non-linear nature, the power factor, line utilization or power factor will get deteriorated. That is a very, very important point. That's a takeaway point. I'll just take an example for our understanding. In a simple house, like we have different electronic gadgets like this, air conditioners. Using Alexa, we are conditioning let us say that's the order of the day. Using Alexa, you can control the temperature, you can control your CFLs with CFLs built with the sensors. Okay, any device which has a sensor, it's possible to control using Alexa. So It's only a communication device, that's all. So, but otherwise also, even if air conditioners, CFLs, UPS, battery chargers, even a very to 4%, 5 or 6 battery chargers will be there. SMPS used in computers, laptops, fan regulators. We can see 20 years back, we have the resistive type of regulators. Very big box will be mounted on the board. That box is no longer here. We have a solid state regulator. Fine variation in the speed is possible. So induction heating, kitchen electrical appliances, where and all we want a speed control, where and all we want to have a illumination control, UPS, battery, all are built with the power electronics. Okay. Now, if we measure the current, incoming current in our house using a meter, let us say a harmonic analyzer, if we measure the current will definitely not be non-linear. They will not be linear. Okay, it will be highly non-linear. So normally, we are talking about power quality. As an electrical engineer, we talk about power quality. If we take a civil engineer, water quality, air quality, other where and all we are using, the quality is very important. So as the prime importance of an electrical engineer, we should maintain the power quality. So when we, a simple story I normally used to say, Akbar wanted to test the honesty of his countrymen. He kept a pot in the middle of his palace, asking his countrymen to pour milk in that pot. Okay, so countrymen poured something. On the end of the day, when we look into the pot was full of water. So thinking that the other person will pour the milk, every person poured the water. The same way, each one of us are responsible for the harmonic pollution or for the grid pollution. So we draw current, we draw nonlinear current. The same way our neighbor, the same way the pool of systems will draw only the nonlinear current from the, so the entire network will become nonlinear in nature. So the current drawn by the nonlinear, the load is non-sinusoidal, then it will lead to poor utilization, poor line utilization. So whatever the money we are paying, whatever the money electricity bill we are paying is for the kilowatt. Earlier we used to have the energy meter, one disk type energy meter. You would have seen electrode meters in our houses. Now it is no longer there. Now electricity board is going to monitor only the VA, kVA. Be a volt ampere. Denominator power factor is kilowatt to kVA. Earlier, without monitoring kVA, we paid money for kilowatt. Now, denominator they are going to monitor. Okay. Now, because whatever the denominator we are getting kVA, it has to be completely converted into power. Then only whatever the money we are going to give it to the utility, it is worth it. Otherwise, we will be wasting money in the unwanted things. So, how we can maximize that? So whenever when you find any, when you buy any electronic gadgets, look for any sine wave in, sine wave out. If you take an UPS, you can see the terminology: sine wave in, sine wave out. A battery charger should draw a sinusoidal current. But practically, that's what I want to give an important point. Let us say I want to buy a CFL, let us say a 10-watt CFL. The CFLs are available at different prices. If it go to a corner, a roadside wala, he will be giving. I'm not telling. I don't want to use the country's name as of now. It is an open forum. If from a local or from some manufacturer, he may give. It is possible to manufacture a CFL with 10 rupees. The same CFL, if I go for some branded items like Philips or something like that, maybe Pro, then we can get the same. For the same power level, for the same efficacy, we will be getting for 250 rupees, 250 or 300 rupees. No, the person who the same illumination he is going to get with the 10 rupees as well as with the 250 rupees. But who is intelligent? The person, as an engineer, we have to apply our mind. Because the 250 rupees is not for the illumination. The device will have a built-in power conditioner such that the device will draw linear current from the source. Whereas the one which is bought for the lower power, it will create harmonic pollution. That's all. So we may be enjoying momentarily that for a few months or how long, I don't know. So we may be doing for a local a small investment. But if we investment and if we look at the 250 rupees Philips make, then it is worthwhile to investment because it is going to draw a sinusoidal current. Thereby, it will be increasing your line utilization. So similarly, fan regulators. Now we have the fans. The conventional universal motor based fans are being replaced by PM wheel DC machines. Now we can do the speed control by sitting or by lying on the bed, by sitting at the chair. You can control, you can using a remote like a television, how we are controlling a television. You can control the fans, smart fans. They are also, the loads are becoming smart. Okay, like a smart grid, the loads are also becoming smart. They have a built-in sensor and communication, so it is possible. So if we want to do the fine speed control, if it's a conventional fan, they have only 5 steps, step 1, step 2, like that we can go up to 5. But with a super fans or something like that, we can do the smooth speed control, and we can, you can keep it in the with the speed in for at particular speed for some time. We can change the speed. Let us say for up to 3 o'clock in the night, it should be at one speed. After some time, because all these things are possible because built-in sensors and the power electronics is going to help us. So when you buy any electronic gadgets, as far as household appliances are concerned, look for you pay some attention and check whether the current drawn, whether look for the specification, read the specifications thoroughly, and check whether they are sinusoidal source. So they draw whether power factor correction is happening. The same way with the UPS, the same one tabletop computer, 1 kVA UPS, it may cost around 1,500 rupees to 7,000 rupees. Why the same? UPS is AC to DC and battery, and it is converted into AC, same kVA level, same power level. But the cost variation is the front end of the power converter has to draw a sinusoidal current. That's a very important point. So when you buy some appliances for our domestic purpose, look for the specifications, then please go ahead with the purchase. So if we take up an industrial load, I'll just complete with here. So we have different types of loads, adjustable. So let me not take about adjustable speed drive as of now. Even in a single house, large house, people are going for 3-phase connection. Okay, single phase connection, the capacity is small or a simple house. A very big house, people go for 3-phase connection. The very important point is power factor equal to 3 VA cos, the 3-phase power is 3 VA cos phi only if all the 3 loads are balanced. Let us say a ground floor in a house like us, a ground floor may be in one phase, middle floor can be in the other phase, second floor if we have, it will be in other phase. Therefore, if we are not going to utilize the power in a proper fashion, then your 3-phase power factor, the calculation of the 3-phase power factor is different from the single phase power factor, but it will be different. Therefore, by properly managing, by switching over the loads alternatively among the 3 phases, if we are able to do the load balancing in the sense all the 3 loads ought to be equal. Okay, if you are able to balance the loads, it is also possible to have a higher power factor. A 3-phase system, a house with a 3-phase connection will have a lesser current bill when compared to a house with a single phase connection for the same power, active power consumption. That is also okay. There is an important point called the load compensation. The load compensation is all the loads practically in a practical environment, all the loads may not be, even if you take a very large industrial complex or hospital or something, the loads may not be shared properly. But you can make by adding some compensators, by adding some local filters, it is possible to make the source, from the source end, you can do the compensation. That is done with the power electronic devices. Another important point is, this is one end with the load compensation. Another one is, suppose due to some natural disturbances or due to the withdrawal or a sudden connection of the load, the supply voltage may not be at the rated value. There will be sag or swell in the supply voltages. So, but if there is any sag or swell, I just stop with that with one example. If there is any sag or swell, decrease in voltage or an increase in voltage, it may also lead to some malfunction of the sensitive loads. The sensitive loads here, I mean hospitals, semiconductor hospitals, where all the instrumentation gets connected based upon the instrumentation, based upon the readings only, the doctor is going to take some action. Therefore, the sophisticated instrumentation for it to work, the voltage has to be at the correct value. And the semiconductor industry, even a single glass manufacturing industry, if you take a glass manufacturing industry, they will not depend on the grid supply. Apart from the grid supply, they will have 5 standby alternators. We have Saint Gobain near Sriperumbudur in Chennai. They have 5 standby alternators. Even single cycle loss Single supplies, 20 milliseconds, even single supply loss will lead to the solidification of the glass. You cannot move the machinery. That's a very important point. Therefore, to mitigate this sag or decrease in voltage or increase in voltage for these industries, we need to have a built-in series connection device so that end voltage may be regulated. So these and all we need to have an idea. Almost starting from a milliwatt to megawatt, power electronics finds an application in numerous ways, and whether you can take it as you need not worry about the complexity control. It's a very like a story you can learn about this power electronics. That's how I have learned. Everybody can learn, and wholeheartedly I am telling that you can also pass it on to your students or to your children at home. Whoever is not against electrical engineering. It's very, very simple. That's what I have learned. Definitely, I have put some effort. That's all, and everybody can learn. That's my simple understanding over the years. Thanks a lot for the opportunity, Ushaa.
My God, Uma. I don't know, maybe if people go into electrical engineering and talk about power, they get that energy, like Pioneer sir. I'm just seeing one part of Pioneer sir in you. Oh my God, what an energy.
Oh, thank you. There
is no need of any energy transmission from anywhere. You are sufficient for your students.
Actually, if there are any doubts, the audience can ask.
Yes. You stop sharing the screen and we'll ask the...
Hello, good morning, Prabhakar.
Hi. Hello, Uma.
Hello.
Why? Vidya varla enna solradhune, but I'll wait for others.
படிக்காம நிறைய லேர்ன் பண்ணிட்டேன். நான் சூப்பரா இருந்தது. அவ்வளோ இயர்ஸ் எக்ஸ்பீரியன்ஸ் இருந்தா கூட நான் நிறைய தெரிஞ்சுக்கிட்டேன். சூப்பரா இருந்தது.
One thing I wanted to tell here to all the participants and all my classmates, as females, we all say that saree is beautiful, that jewelry is beautiful. And first time I'm hearing Uma saying a beautiful AC signal.
Exactly. That tells.
Oh my God.
She is an electrical engineer.
No, she has gone into the subject to that extent where she started loving the AC signals.
Yes.
Oh my God. Allapan, what is your time now? You are about to sleep?
Uma, power electronics, மழையில நனைய வச்சிட்டு எங்களை எல்லாம். Super presentation, complete presentation I can say.
இது எல்லாமே thanks to our teachers, Dr. Vaidilingam sir, Dr. MC SPN sir, Natarajan sir.
Madam, we also studied in the same sir.
I am able to speak something.
இப்ப நாங்க லேர்ன் பண்ணிட்டது அதுல ஒண்ணே சேர்த்துக்கோமா.
யார் அந்த விருந்தினர்? சுரேஷ் இருக்கிற மாதிரி இருக்கே. ஹாய் சுரேஷ்.
Suresh irukka.
I remember Suresh taught me op-amp summer circuit before our LAC examination.
Oh,
which one?
Op-amp summer circuit.
Oh, I don't even remember.
I remembered because you completed, you finished earlier than me. I was waiting, so you taught me that.
Oh my God, Suresh.
Hey Uma, this is the first time I'm attending an engineering lecture since I graduated my master's. Unbelievable. Your delivery of the content is very, very, like I would say that neutral to any type of audiences. I understood a lot. I just want to understand how the country ranks in terms of transmission loss compared to 30 years ago.
Around 30 to 35% of the power gets lost in the transmission lines only.
And we are ranking low in the country, among the world. Our losses.
Transmission loss is quite high in our country, but I don't know about the data about the other countries.
Okay.
It's a huge loss.
There is a question, Uma. Shivaranjani has asked, ma'am, in static VAR, fixed capacitance can be used for high frequency application because capacitance is connected in parallel. She's asking a question.
Fixed capacitance. Yes, fixed capacitance we can use. Not for, see, fixed capacitance is connected to the grid. In parallel to that, we have, Shivaranjani?
Yeah, just see the chat.
Okay.
In static VAR.
Okay. Okay.
Static VAR capacitance can be used.
Yes. In
high frequency applications. For high frequency applications.
No. Fixed capacitor will work at the 50 Hz frequency. The parallel component, whatever I have shown, it is also made to work with respect to SVC. SVC is in the fax device. It will work at the line frequency, 50 Hz frequency. Don't confuse with the high frequency operation. Sivaranjani? Don't get confused with the high frequency operation. We have a fixed capacitor in parallel with an inductor connected with an SCR. This SCR controls the AC wave at the 50 Hz.
Okay.
Well, I had a question. In the ASD, basically the speed drives you're talking about, in the textile industry, எதுக்காக அதை யூஸ் பண்றோம்? Just to maintain the frequency to a standard, or it's maintain the voltage?
If a textile industry, yes, in the textile industry or paper industry, the thickness matters.
Right.
Okay. The thickness, the speed of it all depends on because rolls are the sheet or the paper will pass on through sliding wheels, sliding rotors, and it will skew and come. Okay, both the rotating part has to run at the same speed. If there are any fluctuations in the supply voltage, it may get immediately reflected in the speed. So we should have a built-in arrestor, something like that, conditioner, so that whatever like a shock absorber in the vehicles, whatever the bumps, we may not feel at the whoever is driving. So this power conditioner will not allow the fluctuations on the supply side to reach the end.
Okay, yeah, it's very the analogy is very similar to in my world rather, where we are using it in, say, for everybody's here in a home theater system where voltage fluctuations are eminent, and that is probably need to be conditioned properly for now to get the best sound in the audio video system. So எனக்கு தெரிஞ்சது நான் சொல்றேன் நான்.
கண்டிப்பா.
So I think that is exactly the same thing.
ஆமா. நம்ம அதுக்காக தான் ரெகுலேட் நம்ம வோல்டேஜ் ஸ்டெபிலைசர்ஸ் போடுறோம்னா ஃப்ரிட்ஜுக்கு கொடுக்குற வோல்டேஜ் ஸ்டெபிலைசரை நம்ம வந்து டிவிக்கு போட முடியாது. கரெக்ட். அது எல்லாமே வோல்டேஜ் ரெகுலேட்டர் தேவை, நம்ம ஸ்டெபிலைசர் தேவை. பட் ஒன்னொன்னுக்கும் ஒரு ரெக்குவயர்மெண்ட் இருக்கு. இப்ப அந்த வோல்டேஜ் ஸ்டெபிலைசர், ஃப்ரிட்ஜினுடைய வோல்டேஜ் ஸ்டெபிலைசரை பாத்தீங்கன்னா ஹெவியா இருக்கும். டிரான்ஸ்ஃபார்மர் ஆர் இண்டக்டர் வந்து ரொம்ப ஹெவியா இருக்கும். இது வந்து கொஞ்சம் பல்கி, இதனுடைய கரண்ட் வந்து ரொம்ப ஸ்மால். அது வந்து கரண்ட்டும் பார்க்கணும், வோல்டேஜ் பூஸ்டிங்கும் பார்க்கணும். Similarly, if you take an air conditioner, இப்போ double boost போடுறோம் நம்ம. Double on the boost box பாத்தீங்கன்னா it will be very heavy.
Yeah.
ஆமா.
Awesome.
Hi, Arunmari.
Uma, you really made me wanted to love the subject again. Seriously, I'm not joking at all, and I want to become a student again based on just your lecture. அவ்வளோ நல்லா இருந்தது. Such a refresher. Thank you so much.
நான் வந்து உங்கள்ட்ட வேற எதுவும் சொல்லல. நம்மளுக்கு நம்ம டீச்சர்ஸ் அவ்வளவு நல்லா சொல்லி கொடுத்திருக்காங்க. Only that made me to have நல்லா அண்டர்ஸ்டாண்ட் பண்ண வச்சது.
எனக்கு தெரிஞ்சவங்க யாருன்னா அந்த எலக்ட்ரிக்கல் எலக்ட்ரானிக்ஸ்னா I will be probably sending it to you for a 5-minute conversation.
கண்டிப்பா.
Amazing. Thank you for the wonderful presentation.
Thank you.
Uma, I feel the same thing whatever Prabhakar said.
Thank you.
Suresh, எப்படி இருக்க?
உமா அருண்மொழிங்க.
அருண்மொழி ஏன் நம்மளுக்கு சீனியர் நீங்க இருக்கும்போது நான் கொஞ்சம் அமைதியா தான் இருக்கணும்.
ஹலோ, நான் சீனியர்
படிப்புல
அதெல்லாம் ஒண்ணும் கிடையாது. பட் என்ன சொல்றது, இந்த சப்ஜெக்டுக்கு ஏத்த மாதிரி அப்புறம் ஐ ஹோப் someday நீங்கலாம் சேர்ந்து
I'm unable to hear.
Hello, can you hear me?
இல்ல கேக்கல, இன்னும் கொஞ்சம் கிட்ட வா அருண்.
Hello, can you hear me?
Yeah.
நான் என்ன சொன்னேன்னா இது எலக்ட்ரிஃபைங் பிரசன்டேஷன் சப்ஜெக்ட்டுக்கு ஏத்த மாதிரி. And
எல்லாரும் கத்துக்கலாம். See, நான் அதான் yesterday I was talking to Mangai. I need to survive in an electrical department. I have to learn. That's what I did. I just started learning few by taking appropriate books. Selection of the books are very important. Other nalla books, nalla sources. Being in the city, that is also one of the best resource to look into other IITs. அது மாதிரி போறதுக்கு I had an opportunity.
and hopefully
you should have that passion.
Yes.
That is what we are seeing here, the passion towards learning and teaching.
Uma, you are talking about the power electronics reducing the size. So, like, one of my pet problem is that I hate the size of the power supplies of our laptop. When you travel a lot, this laptop has become sleeker and sleeker, but the power supply of the laptop is not anymore designed improved.
இல்ல அதுதான் உங்களுக்கு எப்படி உங்களுக்கு ஸ்லீக் வந்து செமிகண்டக்டரும் உங்களுக்கு நானோமீட்டர் லெவல்ல they started manufacturing. அதே சமயத்துல உங்களுக்கு வந்து கண்டிப்பா நீங்க ஒரு 5 years பேக் உள்ள லேப்டாப்க்கும் இப்ப இருக்கிற லேப்டாப்க்கும் SMPS வந்து கண்டிப்பா வெயிட் ரிடக்ஷன் இருக்கு.
But my pet project is you tell all your students go and design a sleek power supply.
Yes.
There is a huge market for it.
Yes. Definitely.
Unfortunately, the education policy also has promoted.
Ushaa?
Yeah, Prabha. Hi, Prabha.
Uma, it was fantastic, Uma.
Thank you.
It is so nice to, get connected in a very nice way.
Normally in the class, for measurements and instrumentation class, we used to take notes only from Prabha.
No.
We used to write very neatly in the Lincoln Sir's notes. We used to copy from there only.
No, Ushaa, it's not that. You won't believe the same Beckwith and Buck and the measurements book. Now I'm looking into sensors and measurements for biomedical applications. I go back to the same thing. Okay.
Same thing. Okay, good. Yes. I used to sit next to you during the Lincoln Sir class.
It is nice.
Very nice to see all of you.
Yeah. Only to see. Ma?
Yes.
நான் எது பர்ச்சேஸ் பண்ணாலும் உமாட்ட டிஸ்கஸ் பண்ணிட்டு தான் வாங்க போறேன் நானு.
Oh, Uma is basically like a pro in the academics. Yes. I am just, I'm an accidental academic. So it's okay, I will keep it that way.
I also got a telephone opportunity.
I would like to... Uma. Uma?
Yes.
Can you hear me?
Yes, Radha, please.
It was really a fact that you were bubbling energy and level.
Some takeaway point இருந்ததுனா எனக்கு அது உபயோகமா இருக்கும் அவ்வளவுதான். வேற ஒண்ணும்.
I think I would like
she wanted to sit and present. She wanted to stand and teach.
The linear வந்து Uma, non-linear the entire group.
இல்ல எவ்வளவு அழகா வந்து she was giving an example. சொல்ற பேச்ச கேக்குற பசங்கன்னா லீனியரா
நம்ம எல்லாம் non-linear.
See, but non-linear is the challenge in the world, okay?
Yes. அதான் systems not எல்லாமே non-linear தான் இருக்கும். Only very rare. Percentage of linear systems very small.
And if you have if you have a linear system, your job is reasonably straightforward.
You don't have to do anything. You cannot take the credit.
Yes.
Yeah. So,
Uma, what about your PhD students? Are they all doing work in power electronics? Or
Yes, they are doing in power electronics, electromagnetic interference.
Okay.
Converters for wind farms, solar.
Okay. Yeah, I'm also one student of Uma.
Oh. Thank you so much for all the 5.
Ushaa, this whole week has been wonderful. A small idea which we discussed over texting on the WhatsApp materialized, and it took a great shape, and we kept it going, and done. It's a very beautiful experience what we had.
Yeah, thank you for all the participants also, and all our classmates for encouraging us and motivating all of us.
Thanks a lot for all the friends. Thanks for
no,
your
but thanks, and I just realized from is that so much refresher for us from our college days, because some of us were not even close to our subject, doing something else.
Yes,
a great refresher. And the best part today, as Ushaa said, beautiful sinusoidal wave. Uma said.
The way she was admiring the subject, like.
Arunmozhi, I felt like a T20. Arunmozhi, I felt like a T.
Class, I felt I was in the classroom today.
Arunmozhi, I felt like a T20 innings. Like, man, she was like a full form, like unbelievable. I wish we had every lecture like Uma, but unbelievable.
The same content we can teach for 3 hours.
To comment as action movie. For some faculty, they'll be saying, action movie has started like that. They used to comment on us.
Ushaa, one request, Ushaa.
Hello, Suresh.
Future la வந்து கொஞ்சம் கலிபோர்னியா பீப்புளையும் கன்சிடர் பண்ணு. 4:30 மணிக்கு எழுந்திருக்க விஷயம்.
நீங்க பார்க்க வருவேன்னு எனக்கு என்ன தெரியுமா? சரி, நம்ம அங்க இருக்கிறவங்களே பேச வச்சிடலாம். அப்ப கண்டிப்பா டைம். So Suresh, you will be the first speaker.
Sure.
Lala, அது இன்னொன்னு வந்து I also noticed when Uma was saying in the transportation அதெல்லாம் unwanted work. Educationக்கு ஸ்பெண்ட் பண்ணும்போது அது யூஸ்ஃபுல் வர்க்னு சொல்லும்போதே தெரியும் உமாவோட கேடர்.
இல்ல, நான் ஒரு எக்ஸாம்பிளுக்காக சொன்னேன். அது புரிஞ்சுக்கிறதுக்கு.
Beautiful, no, that's see what you think is what comes around is what I'm saying. Very good.
Are we done or is...
Yes.
Nallappan,
we are still there.
Nallappan, நீ ஏதோ டவுட் கேளு.
No. I'm still not recovered from the presentation.
இல்லப்பா, நடுவுல ஏதோ உமாவை கேளுன்னா நடுவுல பேசவே எனக்கு இடமே கிடைக்கலையே நடுவுல உமாவை இன்டரப்ட் பண்றதுக்கு.
Uma, she was like bulldozing like boom 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 like
பாவம்.
I had some on EP, but I could not present due to lack of time.
It's enough, Uma. You keep it for some other day.
Thank you. We know only talk. That's why talk and talk we are doing. No other.
Don't spend more than 3 minutes in a chat. That's,
yes.
Just move on.
Yes, that's true. We can't concentrate more than 40 to 50 minutes.
Correct. As I was telling Ushaa, just maximum 2 to 3 minutes per slide. Just move on.
Yes.
நல்லப்பன் கொஞ்சம் மூஞ்சி தெரியற மாதிரி கொஞ்சம் adjust பண்ணேன். I'll take a picture.
Okay. Is it okay now?
Yeah, smile all of you. Yeah, that's it. So thank you so much. We'll all meet in the another session. Maybe we'll have all you people guys. Suresh, Nina first.
Replay வரல.
இல்ல, அவன் மியூட்ல இருக்கான்.
I'm sorry. Yeah. I can do it. Yeah, but I don't know what subject I have to do. I'll think about it.
Prabhakar, Suresh, Arunmozhi, Nallappan.
ஐயோ, நான் இல்ல அருண்மொழிக்கு முன்னாடி நல்லா ஒண்ணுமே இல்ல. அருண்மொழி டெஃபினட்டா
கேளுங்கப்பா. I just wanted you to throw light about the industry scenario there, education scenario there. இன்னும் என்ன பண்ணலாம்? You can have a panel discussion. Like தனியா இந்த மாதிரி presentation பண்ண வேண்டாம். We all can have a panel discussion. ஒரு 4 பேர் நீங்க வந்து you can talk about your industry and then give some ideas. இருக்கிறவா இன்னும் how they can update themselves. எப்படி இருக்கு world என்னெல்லாம் expectations இருக்கு, fill gap எல்லாம் எப்படி bridge பண்ணலாம். See, come out with some new things which will help the students as well as the teaching fraternity. So that will be interesting. You can all decide on the discussion. Taniya presentation mari panna vendam. We can have a panel discussion. Because you're all there, no? Ellame abroad la irundhu pesreenga. You will know what is the standard there and inna level la poirukanga updations ella engalukku theriyadilla. So think about it. Aranmari, I know you already give talks. I have your links.
As you said, panel discussion. So maybe we'll. Yeah, I'll think about it.
Yeah, please. I'll be very happy if you could contribute. So,
sure.
Thank you all. First of all, thank you for all the speakers. Anjanal, you made it. Really, I feel really proud of you all. Thank you for all the cooperation with all the right time, right presentations. Whenever I called, you came. And thank you so much for all the cooperation and all the participants. Also, I'm thankful. And the feedback link will be shared in the group. And also for all my classmates, thank you. It's like a small mini reunion.
Yes.
Yeah, sure.
All of us are very happy to see you all. And so
thank you. Thank you. Bye-bye.
Bye-bye.
Thank you.
Yeah, bye.
Thank you, Ushaa. Thank you, Prabha.